Good morning, everyone. What we're going to go over this morning is a basic hello world in 64-bit assembly. So the first thing we need to do is define our data section. Now our BSS section for uninitialized data would be above this, but we don't have any uninitialized data. So here's where we're going to put our string we want to print, and we're going to define it by bytes. That's what the DB stands for. And we'll do feeling groovy. Felling? How about feeling? Feeling groovy. And that's going to be our string we want to print to the screen. So unlike C where we just hit print, we have to do a little work here. So that's the data section. Next, we're going to define our .text section. And this is where all our executable instructions go. So the first thing we need to do is define the start label, and the start label is the same as the main in C. So we define the global start, and then we just come down here and we start with a colon. So now when the program runs, this is where it's going to start. So now our executable code. So first things first, we'll go back to our working files here and open terminal here. So now I have assembly buddy there to help me find all the syscall numbers that I need. So we will haul assembly buddy up. So now the first syscall you're going to need is the write syscall, and you need to find the syscall number and then the parameters that go with that out of the man2 page. So this program does both for me. So I just type in write, and it takes the synopsis from the man2 page here. So with this write syscall, so write syscall 1 is going to go into the RAX register. That's where all the syscalls always go. Here with the write, we need an integer file descriptor. So we're just going to put in 1 for that. We're going to need a buffer pointer here that points to our string, and then the size count. So it's going to be 4 instructions. So RAX is going to get this one. RDI is going to get the file descriptor. Our SI is going to get the buffer pointer, and RDX is going to get the size and the count. And that's just a count of our string. It'll be really simple once we get back into our program here. So first things first, now we're going to get into the actual assembly, 64-bit assembly instruction. So we move into RAX 1. Okay, so that's our syscall number, and this is the way every syscall lays out. The first syscall goes into the RAX register. Next, we're going to move into the RDI register. We're going to move into the RDI register, the file descriptor. So the file descriptor is just going to be 1. You can use anything here, but just remember that every function that gets sent up like that is, like for the write here, is going to need a file descriptor. So that's 1. Next, we're going to move into our SI. This is going to be our buffer pointer, and it's going to point at this string. So what do you do instead of move? You use load effective address into RSI. Then we use our square brackets here to grab the string. STR. So now our string will be loaded here. Now the last thing we need to do is the count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we need 14 bytes. So we're going to move into RDX 14. Now we need to put an exit function on this, or it will cause a segmentation fault, of course. But what I'll do, just for fun here, we'll save as, let's save it as 1.asm. So let's go and jump into this one. So let's assemble it. So you need file ELF64 1.asm. So this is going to create our object file. So now we need to link it. So LD 1.o, which is our object file, and output 1. So now if we run 1, you can see we get a segmentation fault. So it does not print to the screen. So now we need to go in and we need to put in our exit function. So let's go back to our assembly buddy here. And let's put in exit. And here in the synopsis from the Man2 page, you can see we only need one parameter, and that's the status of the exit. And the status of the exit successfully is 0. If there was a problem, it'd be 1 for an error. So we need to put a 0 into the RDI register. And then you can see the exit function, which always goes into the REX, is 60. So let's go back and let's put in move into REX 60 for the exit. And sorry about that, but I forgot the syscall right here, and that's why it didn't print. So there's the syscall, move REX, and then we need to move into RDI 0, okay? And then, of course, I have to remember my syscall. So as you can see, the assembly buddy makes it really quick because you'd have to go to like 2 places in order to get that info. So I did a bit of bash, and it saves me so much time. So we can save this program, and let's go back to our working files, and let's create our object file. And now let's link it. And now when we print 1, all you can see is feeling groovy, and everything worked perfectly. So that's how you do a Hello World program in assembly. This is where you need to start if you want to build shellcodes and get into shellcoding. You need to understand the basic syscalls of EXECVE and things like that. So what I'm going to do over the next maybe 10 weeks is start putting together small classes on assembly, just so I can get up to speed and get everyone else up to speed. And then we'll start doing some 64-bit exploitation, which is a lot of fun too. This may seem hard at the beginning, but once you get into it, and this is my second assembly language I'm learning now, and the second time around, it's so much more fun because I feel like a genius because I know a lot of how things work. Using registers instead of the stack is something I'm getting used to, but I'm having a lot of fun. So hopefully you enjoy this. This is how you do Hello World in assembly. We got feeling groovy. And that's all I have. So I am on vacation this week, so there will be less posts because I'm having fun with some real world stuff with family. And I will be back later in the week with some more assembly for you guys. So I hope you guys enjoyed, and I'll see you soon.